What do coal mines and software deployments have in common? Both of those can use canaries to make sure that it is safe to proceed. So let's explore canaries. I will not talk much about coal mines, but I will explain how to do canary deployments in a Kubernetes cluster. In the past, miners would bring canaries to mines so that they get early warning that there is something wrong and that they should abandon whatever they're doing. If there were toxic gases in a mine, canaries would die first. Now that's horrible, and I do not think that that's used anymore, but it is very similar to what we are trying to do with deployments. We want to know that something's wrong so that we can roll back or abandon the process, so that we can fix the situation before something wrong converts itself into disaster. Now, canary deployments are only one of the flavors of progressive delivery. By default, Kubernetes uses rolling updates, then we have blue-green deployments, A/B testing, and quite a few others. I will not go into details of different flavors of progressive delivery. If you're interested in those, I have a video with the title Progressive Delivery Explained or something like that, where you can see what progressive delivery is and what are the differences between different flavors. Today we are going to focus on one of those. We are going to focus on arguably the most interesting type of progressive delivery, which is canary deployment. And to implement canary deployments, at least in Kubernetes, we need two things. We need a service mesh, and we need a tool that will be changing weights of the traffic going to one release or another. For service mesh, we will use Linkerd, and for canary deployments themselves, we will use Flagger. Flagger is one of the projects under Weaveworks umbrella. I think it's awesome, and it's one of the two tools that I think are worth considering for progressive delivery. That would be Argo Rollouts and Flagger. Both of them are awesome, and since I had to pick one of those two, I will use Flagger today. If you would like me to show you the same process with Argo Rollouts, just let me know and I will do another video that will do more or less the same but with Argo instead of Flagger. So here's what we are going to do. We are going to deploy new releases in a way that they are gradually increasing their reach. We will be exposing those new releases to a fraction of users, see how it's going, how they're reacting, and then if everything goes great, we're going to increase the reach of that new release, let's say from 20 to 40 to 60%. And at the same time, we will be decreasing the amount of traffic going to the old release. So if this is the amount of traffic going to the old release, being 100%, and this is the new release, we will be doing something like this. As long as everything is going fine, we're going to continue increasing the traffic going to the new release at the expense of the old one. Or if things go wrong, we will just abandon the process and roll back to the old release. And there are quite a few more or less obvious benefits of those. To begin with, we want to monitor how users react to our release and then make decisions and do all that in an automated fashion. So hey, is this successful? What is the error rate? What is response time? And so on and so forth. And if that's going well, progress further and further and further. You can think of that evaluation of metrics as a way to decide what to do next as a form of testing in production. Except that instead of having automated tests that are performing some actions, we have live users performing some actions on our application. So we are measuring reactions of humans instead of measuring reactions of machines to deduce whether everything is okay. I will stop with talking right now and jump into a demo, and then while we're seeing it in action, I will explain in more detail how it all works. So let's go and set it up first. First things first, I already created the cluster and I already installed Linkerd. I will not show you how to install Linkerd because I assume that you're already familiar with it. And I'm making that assumption because I'm guessing that you already saw the video that I made, the video that provides an introduction to Linkerd. If you haven't, the link is in the description. So if you know nothing about Linkerd, stop this video, go and check the video about Linkerd itself, and then come back here and then we'll continue. I'll wait. I mean, I will not wait, but you can pause the video and then you imagine that I'm waiting for you to see the other one. So the only thing really missing is to install Flagger itself. Installation is simple, it's straightforward, except that there is no universal installer. You need to apply the manifests that match service mesh that you're using. So I'm going to execute kubectl apply, and then the address, which is the customized Linkerd directory inside the Flagger repository. And that's about it. That's all we need. Now we can deploy new releases of our applications using Canary deployments. So let's deploy a demo application, and I already have one prepared for you. It's in a directory of a repository that I'm using, the repository that contains all the manifests, and that just reminded me that I created a gist with all the commands, including the repository with all the manifests, and the link to the gist is in the description. So if you want to reproduce what I'm doing or follow along, please do not pause the video and try to read from a screen and then write the same thing. You can just copy and paste the commands. That's so much easier. Use the gist. So I'm going inside of the directory that contains all the manifests that I will use today, and I'm going to show you those manifests. There is nothing special. Actually, there is something special, but most of the manifests are just typical Kubernetes manifests. There is a deployment, a horizontal pod autoscaler, and ingress. All those are Kubernetes resources you're probably already familiar with. They have nothing to do with Canary deployments. So there is nothing additional, nothing extra, at least so far. The only thing worth mentioning is that there is something missing. I did not define a service through which other processes or users should be able to access this application. And I did that intentionally because Flagger will be created the service for me. That's very important. That's part of Flagger design. It needs to be in control of the services it creates so that it can control which percentage of traffic goes where. The only additional resource that I had to define is Canary itself. It's a resource based on custom resource definition that was created when I installed Flagger. It defines all the resources that Flagger should create, that Flagger should manage, and metrics, and quite a few other things. So let me go through it and explain what it does. To begin with, I'm telling Flagger that my ingress is Nginx. That's important because ingress is not baked into Linkerd, and that means that we could use almost any ingress controller together with Linkerd, but the downside is that we need to tell Flagger which ingress it is. And apart from specifying the provider itself, which in this case is Nginx, we need to also provide the reference to ingress so that Flagger knows how to manipulate it. Then we have target reference that points to the specific deployment of our application. Further on, there is the reference to horizontal pod autoscaler. You will see later what Flagger does with those references. For now, let's move on and see what else do we have there. There is information about the service, but unlike deployment and HPA, it is not a reference. It is a specification of the service that Flagger itself will create for us. And finally, there is analysis. This is what Flagger will be using to decide what to do and when to do it. I am setting the interval to 30 seconds. That means that each iteration of the progression of Canary deployments will be performed every 30 seconds. Threshold is set to 3. That means that the analysis needs to fail 3 times before Flagger decides to roll back. Maximum wait is set to 60. As a result, the Canary deployments will be progressing until they reach 60% of the traffic going to the new release, and after that it will jump straight to 100%. Now you might be asking, hey, why doesn't it continue progressing with the same pace until 100%? But when you think about it, it might not make sense to do analysis when you're, let's say, 80%, because hey, if you reach certain threshold, in this case 60%, you can say everything is almost certainly fine, I can just fast forward to the end of the process. Step wait is set to 20, and that means that each iteration will be jumping by 20%. First, it will send 20% of the traffic to the new release, do some analysis, and then jump to 40, and after that to 60. And since 60 is the threshold, the next iteration is going to be 100%. Finally, we have metrics that Flagger will use to evaluate whether to move forward, to pause, or to roll back. In this case, I'm using a simple example with only 2 metrics that happen to be baked into Flagger. We're going to measure request success rate, and the threshold is set to 99%. That means that Flagger will consider the new release successful only if at least 99% of the requests are successful. If the total amount of requests within an interval of 1 minute is below the threshold, Flagger will consider it a failure, and then it will pause the progression and then it will try again, and if it's still unsuccessful, pause one more time, and then pause one more time until it reaches the threshold of 3, and at that moment it will roll back. Similar story is for the request duration, which is actually average request duration, which has the threshold set to maximum of 250 milliseconds. An interval, the measurement interval in this case, is set to 30 seconds. Now those two analysis metrics are what comes out of the box. We can implement them easily, but Flagger allows us so much more. We can hook it into metrics storage type of solutions and write any query that we want. We could use Prometheus, Datadog, Amazon CloudWatch, New Relic, Graphite, Google Stackdriver, InfluxDB, and Dynatrace. I think that those are all currently supported ones. I might be wrong. There might be a few others that I just forgot about. So what we can do is write custom metrics, or to be more precise, custom queries. We can instruct Flagger to execute any query in any of those solutions, and if the outcome does not pass certain threshold, then it will be considered a success, and otherwise it would be a failure. So the analysis can be anything that we are capable to express as a query in any of the supported data stores. As a result, the amount of possibilities is close to infinite. I mean, whatever we can write as a query can be considered as one of the criteria for Canary deployments. Now let me deploy the first release of this application. I will use Customize for that. If you're not familiar with Customize, again, the link to the video is in the description, and it's not really hard. All I have to do is execute kubectl apply --customize, and the source is dot, which means the current directory. Now let me take a look at the pods, but before I do that, let's think about what should be the expectation. If I wouldn't be using Canary deployments, there should be one pod of the application, at least initially, and then once HPA or horizontal pod autoscaler kicks in, there should be more than one pods, depending on the amount of traffic and so on and so forth. Let's see whether that's what we got by executing kubectl, etc., get pods. Now this is different. This is not what you would expect if you would deploy that application without Canary deployments. There is indeed silly demo pod, the first one, because HPA did not start working yet, but there is silly demo primary. I never defined that pod. It wasn't created by the deployment that I defined. It was created by Flagger. Not directly though, it was created indirectly by the deployment, by a copy of a deployment that Flagger created, but I will explain that later. For now, what might be important to understand is that Flagger creates copies of our manifests and then does something with those copies. But we'll get to that. What might be more interesting is to list all the canaries. Those are custom resources based on custom resource definition that were created when we installed Flagger. And since one of my manifests is Canary itself, I should be able to list it and see what I'll get. And here we are. There is one canary called silly demo. That's the one I defined. And the status of that canary right now is initializing. So Flagger did not yet finish doing what it's doing, but it will finish soon. Do not be too excited right now, because Flagger is not doing much yet, because this is the first release. We cannot do Canary deployments for the first release because there must be always two releases: the existing release, the actual release, or the old release, and the new release. So old release, new release. If there is only new release without the old release, there is nothing we should do from the Canary deployments perspective. Now, if you remember, I mentioned that I did not define the service. I'm letting Flagger deal with services, with creation of services, updates of services. I'm letting Flagger take full control of the services. So let's confirm whether that's really true, whether Flagger created the services, because, hey, I didn't. So the output of get services command shows that there are 3 services. All 3 were created by Flagger. Silly demo is the main one. That's where all the traffic comes from outside the cluster or from other services that want to interact with this application, and then that one redirects to Canary or primary depending on the state, the step in the process, and so on and so forth. Speaking of the process, let's describe the Canary resource and see the events. Let's see what happened so far. And there isn't much to talk about, at least not yet, because remember, this is the first release. There is nothing special for Flagger to do except to set the scene for the upcoming releases when it will do the actual process. It's not very exciting, at least not yet, but the excitement is coming. That was enough of a foreplay. Let's deploy the first Canary release, or to be more precise, let's deploy the second release, and Flagger will apply Canary processes for that release. Because now we have one, and we are about to deploy the second one, and then it can do the dance, you know, up and down between the different releases. Since I'm using customize, I will execute customize edit set image and change the tag to be 103, and then I'm going to apply modified manifest, and we're going to see what we'll get. Actually, to see better what we'll get, I'm going to generate a bit of traffic. I will create a loop that will be executing get canaries so that we can see what's going on, and also send a request to the application and then wait for half a second and repeat and repeat and repeat. So I will be outputting the status of Canary resources and also sending requests to the application. Let the games begin. At the very beginning, the status is initialized, but wait is set to 0. That means that all the requests are going to the old release. And we can confirm that through the output of the request that says this is a silly demo version 102. And it will continue like that until it starts progressing and moves to the weight of 20%, because that's the step that we defined in the manifest of the Canary release. And while waiting for that to happen, this might be a great and amazing opportunity to show that you like this video by clicking the subscribe button and clicking the like button. And if you really like this video and other videos that I'm making, you might want to support the channel by joining it. So just click the join button. Do it now, right away. I'm watching you. Okay? Are you clicking the join button? I'm kidding. Let's move on. The weight is now set to 20%, and that means that approximately, not exactly, but approximately 80% of the requests are going to the old release and 20% are going to the new release. And we can observe that through the output of the request that sometimes returns 102 and sometimes 103. Approximately 20%, or 1 for every 5 requests, are returning 103. And while that is happening, while part of the requests are going to the new release and majority to the old release, Flagger is evaluating metrics. It is checking whether all of them are within the threshold, and if they are, soon it will move to the next iteration. It will increase the weight of the Canary release to 40%. And there we are, the weight is now 40%, so almost half of the requests are going to the new release, while all the others are going to the old release. Or to put it in other words, the amount of requests that are reaching the new release increased from 20 to 40%. During all this time, Flagger continues evaluating metrics and making decisions whether to continue progressing or to stop for a while and then roll back. So let me fast forward a bit. And now it is 60%. The story is the same. It is still evaluating the metrics. Everything is looking okay. So it's increased the reach of the new release to 60%. And now we fast forward again. There we go. And now it is promoting. So it did not go from 60 to 80 because I defined that 60 is the maximum, that it is the ceiling after which it should promote the new release to production. And promotion in this case means that it will start redirecting all the requests to the new release. Soon the promotion will be done, and that's about it. So let me cancel this loop and describe the Canary, because you will see the same explanation that I gave you as events over there. So there we are. We can see that the new revision was detected. That's the new release. It scaled up the production deployment. That's a copy of the deployment. That's the one that Flagger created for us by making a copy of what I applied, and then it started Canary analysis. So it started analyzing the traffic going to that release. Then it advanced to 20% of the requests going to the new release, and after that to 40, then to 60, and then it copied the specification to the primary deployment. That's the one that is considered production, and it rerouted all the traffic to it. The promotion was completed, and now all the users, without exception, are using the new release. Now, if you're still confused about what's really happening, a drawing might help. To begin with, we have Flagger that uses Kubernetes API and some metrics storage like Prometheus in this case, but it could be others which I mentioned before like Datadog and so on and so forth. And it uses those two, the API and metrics, as sources for analysis to decide what will happen next. It also created 3 services. One that is splitting traffic, and it is splitting traffic between the other two services, one being called primary and the other one called Canary. And those services are redirecting traffic to the old release or the new release, depending on the rules that Flagger is setting in the main service. To begin with, all the traffic is going to the primary service, that's the actual release, and then once we deploy a new release, it starts redirecting 20% of the traffic to the new release and 80 to the old one. And if evaluation of the metrics continues providing the results that it expects, it changes those weights to 40, for example, to the new release and 60 to the old release, and then 60 to the new release, 40 to the old release, and then it copies the definition of the Canary release to the primary release. That's the one that will stay in production forever, or at least until the new release. And once the definition is copied, it redirects all the traffic to it. Now let's see what will happen if I deploy yet another release, but this time the purpose will be to see what happens when things go wrong. So first of all, I will change the release to be 104. And then I will apply those changes just as before, and I will create yet another loop, but this time the loop will be different. Instead of sending requests to the application just as before, I will simulate failures by sending two requests, one a good one and the other one that has query parameter fail. The application itself, the demo application, already has the logic that it should respond with 500 response code instead of 200 or OK whenever that query parameter is present. So I will be simulating failures instead of really generating real failures, but that should be good enough to demonstrate how Flagger works and how it behaves when things go wrong. And in this specific case, the error rate should be below the threshold. So let me execute the loop and see what we'll get. So far the status is succeeded. That means that Flagger did not yet detect that the new release was deployed. So all the requests are still going to the old release, the one that says 103. Let me fast forward a bit. There we go. Now it is saying progressing. Soon it will start redirecting 20% of the traffic to the new release, to the one that says 104. Fast forwarding again, and there we go. Now the weight is set to 20, and approximately 20% of the requests are responding with 104, while majority of the others are responding with 103. So only a fraction of the requests are going to the new release. Let me fast forward a bit more. Now, even though I'm generating failures, it still progressed to 40%. The reason for that is in the scope of the metrics it is evaluating. Queries are based on period of time. We are still getting the majority of the requests before I started introducing failures. That's normal because in real world situation, the iteration wouldn't be 30 seconds, it would be longer than that. And we would have real traffic, not a few silly requests like what I'm sending right now. But soon it should kick in. Soon it should discover that there is something wrong. So let me fast forward a bit more. It stayed on 40% for a while because I set the threshold to be 3. And that means that it should fail 3 iterations before it rolls back. And each iteration takes, I think, 30 seconds, so it took a while. However, since the first failed iteration, it stopped progressing. Even though it stayed on 40% for a while longer, it did not move to 60% because it detected, hey, there's something wrong, I should not continue progressing, but I'm not yet ready to make a decision to roll back because there should be 3 failed iterations. And after all that, it did fail, and the weight was set to 0, meaning that no requests are going to the new release. And we can see that from the output of the request. Now they're all returning 103, which is the old tag, the old release. So after 3 unsuccessful attempts to be within the desired threshold, it decided that this is not worth it. Life should not continue going into that direction. We should roll back to the previous release, and that's what it did. And to confirm what I'm saying, I'm going to describe the Canary and see whether events are really agreeing with my description of what happened. So here we go. The new revision was detected, then it advanced the new revision to weight 20% going to the new revision, and then it started the analysis, and everything looked fine for a while, so it decided to advance to 40%, But then the collective metrics over a period of time started returning results that are below the threshold. In the first iteration, the success rate was 90.94%, and that's less than 99%. And it continued dropping, so the second iteration was 83.6%, which is still below 99%, and the third one was even lower with 82.05%, which is still below 99%. So I decided to roll back and to scale down the new release. We are safe from potential disaster. Only a fraction of the users experienced that faulty release, and there was nothing for me or any other human to do to make all that happen. If this would be a real-world situation, the only human action would be to get the notification. By the way, Flagger can notify you of the problems, but I'm not exploring it right now. And once we find out that there is a problem, go fix the problem, create a new release, and then repeat the process with the new release that includes the fix. Now let's talk about additional features that I might not have time to demo, but you might need to be aware of. To begin with, there are webhooks. We can trigger them depending on different conditions like confirm rollout, pre-rollout, rollout, etc., etc., etc. And through those webhooks do different things. We can notify Jenkins or Argo rollouts or Tekton to execute some build pipeline. We can use those webhooks to send notifications, even though there is a different, potentially better way to do that, but we could do that as well. Or we can use webhooks in any other way. As long as the destination has an API, we can send a message to that API to do something, whatever that something is. Another potentially good thing, which you should avoid if you can, but sometimes you cannot avoid, is manual gating. So if you don't want to have all the process automated, you can have manual gates through which Flagger would wait for a manual approval to progress to the next stage, whatever the next stage is. And finally, we have alerts. We can send alerts to Slack and to Microsoft Teams. Those are not the only destinations we can use, because remember, with webhooks, we can send anything, anywhere, but those are the alerts that are coming out of the box. If you're not using either of the two, then use webhooks to accomplish more or less the same thing, even though it might take you a few minutes longer to set it up. Finally, there is monitoring. Now you can collect metrics of Canary deployments in the same way as you would collect metrics of anything else in your Kubernetes cluster. You can use Prometheus or any other tool that you want. And you can continue using Grafana or any other visualization tool, because metrics are there. You just need to collect them and you need to visualize them. But if you want Flagger to help you out, at least initially, you can use pre-built dashboard for Grafana that Flagger provides for its users. And those are some of the features I wanted to mention. There are others, so go and check the documentation. I will not bother you with everything else it can do. What I will do instead is jump into conclusion. Let's talk about Flagger and let's see what are the pros and cons of using it. Let's start with cons, because there is only one. There is only one thing that I do not like within the context of using Flagger with Linkerd. Only Nginx and Glue ingresses are supported. So if you're using any other ingress, it will not work, or to be more precise, Flagger will not work with any other ingress. It will still work for internal services, but not for those with traffic coming from outside, for the traffic coming through ingress, unless it is Nginx or Glue. And that's unfortunate, because my favorite is traffic. Now let's jump into pros, because there are a lot of good things about Flagger. To begin with, Flagger supports all the important progressive delivery flavors. We can use it for blue-green deployments, for A/B testing, and for Canary release. And those are more or less all the important progressive delivery flavors, with the exception of rolling updates. But rolling updates are not really based on metrics, and they're already baked into Kubernetes, so it's okay that Flagger is not doing anything with it. Next, it supports a variety of service meshes. It supports quite a few of them. You can use it with Istio, with Linkerd, with UpMesh, with Contour, with Glue, with Nginx, even though Nginx is not a service mesh, at least not in this context. Skipper, which I never used, I do not know even what it is. Traffic and Open Service Mesh. Then we have data sources. It supports quite a few of them. There is Prometheus, which is a golden standard of sorts, but also Datadog and Amazon CloudWatch, New Relic, Graphite, Google Stackdriver, InfluxDB, and Dynatrace. There might be others, but I think that those are the 8 it supports. And those are the major players, or most of the major players anyways. And finally, webhooks are really awesome. There are quite a few supported events, and you can use them to notify humans or machines. You can use them to execute additional processes, whatever those processes are, in any given moments in the life cycle of Canary deployments in this case, but the same applies to blue-green and A/B testing. And finally, the last one is that it is extremely easy. The only thing that might get a bit complicated is to write your custom metrics, but that's not fault of Flagger. That's the complexity of queries themselves. Outside of that, it is extremely easy. We just define like 20-30 lines of YAML and off we go. We have Canary deployments or blue-green or A/B testing doing the work for us. And that's absolutely amazing. I strongly recommend using Flagger. The only alternative that might be worth exploring, that might be a bit better or might be a bit worse, would be Argo rollouts. I'm not going to compare those two in this video, but if you want me to do that, just let me know and I will put it on my to-do list. Let me know whether that's interesting, and I'm out. See you next time. Cheers.